The surface of our planet Earth is a puzzle of several lithospheric plates drifting on the more fluid asthenosphere below. Those plates are always on the move. Mostly we can't feel their slow motion, but sometimes earthquakes, tsunamis, or volcano eruptions remind us about their existence and how they shape our planet. But there's another place where we can see the results of this tectonic movement very clearly, and that's the deep sea at the hydrothermal vents.
When two tectonic plates move away from each other, magma rises in between, cools down, and new surface floor is created. On several plate boundaries, this process leads to the formation of underwater mountain ranges called mid-ocean ridges. Along these ridges, often a very special process takes place. Seawater flows into the earth through faults and porous sediments, all the way down to 2 to 3 kilometers. Approaching magma chambers, the water is heated up and rises again towards the ocean floor. It is now up to over 400 degrees Celsius hot and rises quickly under great pressure. Its pH level is rather acidic, and so it leaches out various metals and sulfur from the surrounding rocks. As soon as it reaches the cold seawater, the minerals precipitate and form small particles. These stack up along the sides and slowly chimneys are formed. We call them hydrothermal vents. They can be thousands of years old and grow up to 60 meters tall. A lot of the precipitated minerals also leave the chimney as a plume, looking like smoke coming out of an industrial factory. Most of the time, these minerals are black. That's how the vents also got the name black smokers. There are also the rarer white smokers containing different minerals. The dense vent fluid consists mainly of sulfides. You get a sulfide when you combine sulfur with a metal, so for example you will find copper, iron or zinc sulfides in this fluid, as well as some comparably high concentrations of silver, gold and some rare earth elements. Now these minerals disperse around the vent field, settle and form ores called massive sulfides. These depositions of metal are of high interest for economic purposes. A great proportion of the hydrothermal vents are still active today, accumulating the minerals and creating the chimneys. But there are also inactive vent fields, no longer spitting out the hot fluids. These might be more easily accessible for the mining industry, as the equipment used won't have to be specialized for such high temperatures. The actual resource potential and value, though, is still nearly impossible to calculate. The first hydrothermal vents were only recently discovered in 1979 with the research submarine Alvin at the Galapagos Rift. Since then, scientists have found them in every ocean on the planet at depths up to 5,800 meters. Now, as of 2020, over 700 vents have been described. Most of them occur along the mid-ocean ridges, but they can also be found at volcanoes or underwater seamounts of subduction zones, and rarely in the middle of the plates at so-called hotspots. But as most of the deep sea is unknown, it is expected that there are many more hydrothermal vents yet to be discovered. It is even suspected that there might be active vent systems on Jupiter's moon Europe and Saturn's moon Enceladus, and also ancient vents on Mars. A lot more research and sampling is needed to be able to confidently estimate the resource potential of the massive sulfides created by the hydrothermal vents, and if it will be worth the effort and cost to mine them. It is believed that hydrothermal vents have existed for millions and billions of years. They might have already spitted out their hot fluids only shortly after the Earth was even created. Scientists suspect that those vents might have provided the energy and chemical environment needed for the first life on the planet.
You see, the hydrothermal vents are a fascinating landscape of the deep ocean floor. But they don't only accumulate giant deposits of minerals interesting for the human economy, they also host very diverse ecosystems. A lot of animals have adapted, living so far away from the sunlight and at those hot temperatures. In the next episode, I'm going to show you some of those strange creatures, like the Yeti crab or the giant tube worm. If you have any questions about the hydrothermal vents, you can type them in the comments below. You will also find some links of videos and articles under this video. With that, see you in the next one.